Good morning, students. On behalf of Dr.A.Q School System, Shagazi Campus Kohat, I welcome you to this video. This video is about subject mathematics, unit number 1, matrices, exercise 1.5, question number 1. Before going to exercise 1.5, there are some concepts that you need to understand. First of all, determinant of a square matrix. Now, what is a determinant and how can we find determinant of a square matrix? Alright. I will just explain this to you with the help of an example. For example, if we have a matrix A is equal to A, B, C, D, and then we are asked to find the determinant of this matrix, what we will do? We will just multiply A with D, alright, A, D, and then we will multiply this BC, and then we will subtract BC from AD. How do we do this? The symbol for writing determinant is this capital letter A, which is also matrix A, and then we need to write this capital letter A inside these two lines, parallel lines. So this A inside these parallel lines means that this is called a determinant. So also we will write matrix in these parallel lines or perpendicular lines. So what do we do? First of all, we multiply this A with D, AD, and then we write minus sign, and then we multiply these two elements BC. So whatever the matrix is, what do? We will have to multiply these two elements together and then minus, then these two elements together. Alright. Now this method is for finding determinant of any 2 by 2 matrix. Alright, but in case if we have a 3 by 3 matrix, there is a slight change in the method, and I'll show that method to you once we are solving exercise. Now after this, there is another concept which is singular or non-singular matrices. So if there is a matrix which is A, so the matrix A will be called singular matrix if the determinant of A equals 0, and matrix will be non-singular matrix if determinant is not equal to 0. If the determinant is 0, then the matrix is singular matrix, and if the determinant is not equal to 0, then the matrix is non-singular. Now coming to exercise 1.5, question number 1, we need to find the determinant of the following matrices. Now I'm going to solve part 2, 3 and 7 for you. Alright, the remaining parts are just similar, so you need to solve them yourselves. Now question number 1, 2, 3, 4 and 5. Now these 5 matrices are of the order 2 by 2. There are 2 rows and 2 columns. So I'm going to solve 2 questions from part 1 to 5. That is question number 2 and question number 3. And after that, I will solve one more question for you. That is question 7. And this is a matrix G. And in this matrix, we have a matrix of order 3 by 3. So there are 3 rows and 3 columns, and I'll show you how to solve this question. So first of all, let's jump to the solution of part 2, matrix B, which is 4 minus 2, 5, 13. Now matrix B is equal to 4 minus 2, 5, 13. B determinant of B is equal to 4 minus 2, 5, 13 in the perpendicular lines. So 4 multiplied by 13 and then minus sign, 5 multiplied by minus 2. Alright, now determinant of B is equal to 4 multiplied 13 is 52, and then minus minus plus, 5 2s are 10, 52 plus 10 is 62. Similarly, matrix C, 11 7 minus 6 5, we need to multiply 11 with 5 and then minus 6 by 7, multiply 7. So we will solve this and we will get the answer 97. Now Coming to part 7, matrix G is equal to 1, 2, 2, 3, 2, 3, minus 2, minus 3, and 4. Now this matrix is of the order 3 by 3. So we cannot simply imply the method of matrix 2 by 2 to this. There is one more step to this question, and that is, if you have a matrix of the order 3 by 3 in which there are 3 rows and 3 columns, what do we do? First of all, we write G in the perpendicular lines and then the matrix also in the perpendicular lines, and then you will write expand by first row. Now we will expand this solution with the help of this first row. Alright, how do we do this? Just look at this first row. Alright, first of all, you will write in the solution minus 1, and then you will close this minus 1 inside the brackets, and then this is the first element. The address of this first element is first row and first column. So in the power of this minus 1, we will write 1 plus 1 because this is the first row and first column. So minus 1 to the power 1 plus 1. Now what do? We write this first element, which is 1. Alright, now draw a perpendicular line like this. Now if we are expanding from this first row, this is the first column and this is the first row. Ignore this first column elements and this first row elements, so you are left with only these elements 2, 3, minus 3 and 4. So you will write 2, 3, minus 3 and 4. After this you will write plus sign, and then again you will write minus 1, and you will close this minus 1 inside the brackets, and then in the power what you will do, you will actually write the address of this second element of the first row. The address of this is first row and second column. That means 1 plus 2. So in the power of minus 1 you need to write 1 plus 2 because this 2 is actually in the first row and second column. And then you will write the element itself, which is 2. And then again perpendicular lines. And then now you need to ignore this first row and then second column. So you will be left with 3, 3, minus 2, 4. 3, 3, minus 2, 4. Then again you will write plus sign over here and again minus 1, and you will close this minus 1 inside the brackets, and then you will write the power of this minus 1. What will be the power of minus 1? That will depend upon this third element. Alright, this third element is over here in the first row. So this is the first row and third column. So 1 plus 3. Over here in the power 1 plus 3, and the third element is 2. So we write 2 over here. And then perpendicular lines. Now we need to ignore this first row elements and the third column element. So we are left with 3, 2, minus 2 and minus 3. 3, 2, minus 2 and minus 3. Now once you are done with this step, the next step is quite easy. What do we need to do? We just simply need to find the answer of this minus 1 to the power 1 plus 1. 1 plus 1 is 2, and if we take square of minus 1 multiply minus 1 is plus 1, so we will write 1 over here, and then we will simply find the determinant of this 2 by 2 matrix now. So for 2's are 8, 2 multiply 4, and then minus sign, then minus 3 multiply by 3. Now similarly after this you can see that there is this minus 1 and the power of this minus 1 is 1 plus 2, 3. So if the power of minus 1 is an even number, the result is plus 1 always, and if the power of minus 1 is an odd number, the result will be minus always. So minus 1 to the power 1 plus 2, 3, this will be equal to minus 1, and if you multiply minus 1 with 2, the answer is minus 2. Now 3 multiplied by 4 minus 2 multiplied by 3. Similarly, next step, minus 1 to the power 1 plus 3, 4. Now the power of this minus 1 is an even number 4, so this will be equal to plus 1. Plus 1 multiplied by 2 is plus 2. Alright. Now 3 multiplied by minus 3 and then minus 2 multiplied by minus 2. Now we simply need to multiply and solve this. 1 over here, 4 2s are 8, minus minus plus 3 3s are 9. Minus over here 2 and then 3 4s are 12, minus minus plus 3 2s are 6. And then plus 2 and then 3 multiply minus 3 is minus 9 and then minus 2 multiply minus 2 is plus 4. In the next step 8 plus 9 is 17, 17 ones are 17 and then 12 plus 6 is 18, 18 multiplied by 2 over here and then plus 2 minus 9 plus 4 is minus 5. Now 17 as it is, minus 2 multiply 18 is minus 36, plus 2 multiply minus 5 is minus 10. On solving this, we get the answer determinant of G is equal to minus 29, and this is the answer of this question. Similarly, you need to solve part 6 of this question, part 7 of this question. The method is just same. Follow my steps, and still if there is any confusion you can ask me. This is the end of this video. Take care of yourselves. Allah Hafiz.